Hello, this is Justin McBride with the Ohio Department of Agriculture, Division of Soil and Water Conservation. This is the last video for the CAD webinar series for developing a grass waterway plan. This should be number 6 in a total of 6 videos. The previous 5 were held about a year ago, starting all the way from building the topographic surface for a grass waterway and going through the design process of creating an alignment, a profile, assemblies, corridors, and section views. And that gets you all to this point that we're at right now, as you see on my screen. So essentially what I've done is I've went ahead and finished the design for the grass waterway. This is different than the previous videos where I went through the design on screen and you could watch me do it. This step is a little more different in that it's not so step by step in line per se. It's more or less fitting everything that you've done in the previous videos to the specific site itself. Okay, so I went ahead and designed the grass waterway for this site, and it's a finished product at this point. So what I'm going to attempt to do in this video is to go through all of the different little things you need on the plans, like the construction notes and different things like that, as well as how I put together the plan view and some of the other pages that are required in a grass waterway plan. So on this screen right now you can see my model space. There are several things here, some of which you'll see that look familiar from the previous videos, and some of them are new. If I zoom in over to the right here, you can see this big grid here is familiar. This is a profile of the grass waterway. So when I zoom in, I can see that I have the pink and red lines are the left and right banks. The green line is the center line of the proposed grass waterway. It's the existing ground of the proposed grass waterway. And the blue line is the design grade for the grass waterway. The black line below here is just a polyline I drew in that it's supposed to represent the depth and slope of the proposed tile that will go beside the grass waterway. Just below that I also have my my grass waterway assembly for what I'm using in this project, which I won't need on the plans. That'll just stay in the background here in model space. In the bottom left I have the cross sections for this grass waterway that will be put on the plans. And on the right I have some information for some additional practices, in this case a rock chute for the grade stabilization structure at the end of the grass waterway. And those will also be put on the plans. Over to the left here I went ahead and drew a plan view layout of where things are located within the field. And the way I did this is I went ahead and turned on my geolocation, turned on my map, and this may take a few seconds for this to load up. So what I did is I basically turned on the aerial view, and from the aerial view I was able to locate the structures that are in place in the field, and I just roughly sketched them out with a polyline. There's no exactness to this, it's just get it pretty close so that when you bring up the aerial view that you have a good idea where things lay out in the field in relation to one another. So you can see I've mapped out things on this plan view like the stream location here. I've mapped out the pasture that the grass waterway is going through, the pond that is already on site, and the barns and houses and things like that. I've also made the location of the grass waterway here by where the alignment is, so that way I know the grass waterway will come through the property and bend slightly and will eventually exit to a rock chute, which I have that on here as well. So that's the idea of a plan view, is basically a top view as looking down to be able to see geospatially where things are laid out in the field, so that when you're out there checking things you have an idea, you know, where the rock chute goes in comparison to the end of the grass waterway to the stream, and where the two levees might go, and the auxiliary spillway, You know, from this I can see it's on the north side compared to the rock chute. I can see that the proposed tile is also on the north side of the grass waterway. So that's the purpose of a plan, is really to just show you where things should be. It doesn't have to be exactly the way it is out there, but it should be pretty close. So you want to do as good a job as possible to make this detailed so that there aren't any questions to the contractor who's out there building the grass waterway. So I'm going to turn the aerial image off because I no longer need that, because that was really what I used it for, was to go ahead and map out the plan view. So I'm going to turn the aerial image off. And again, all of this here on screen, they're just standard polylines with text. There's some hatching. I use some hatching for the pasture. That just makes it easier to see where that is. I use some hatching for the stream, you know, just so that I know that the stream is easy to follow along this way if I look at it on the plan. Okay, so, but those are really your options, whether you use hatching or not. As long as you get everything labeled right and put where they're supposed to go, that should produce a pretty good plan view map. Over to the left, I have another aerial image picture, which is not from my GeoMap. It's not from AutoCAD. This is a clipped image that I used by using the snipping tool. I pulled up Google Earth and I just found the location where I wanted to go, and I used the snipping tool to zoom into that location and cut it out. I saved it as an image and pasted it here in the model space. The reason I did that instead of going back to where my plan view is and just using layers and turning things off and on and this and that is, in this case, it just made things more simple to keep it separated. That way I didn't have to worry which lines were on which layer and what's showing and what's not on different plan layouts. But sometimes I do both. Sometimes I'll go back to the plan view and just go ahead and start turning these layers off so that it's blank, and turning on new layers that could represent a different aerial image or a different plan view for a different set of plan sheets that I might need it for. But in this case, I just made it simple and I pasted a picture in here. And the steps how you do that is, at least how I do it, is in the command line I type in map I insert. And when I do that, I can hit enter, and I can navigate to where the saved image was that I want, that I created. I can select it, hit open, and this dialog box for the image correlation will come up. And there's a lot of different things you can do. Basically, the only thing I do is I go over to the insertion tab and I select the pick button, which allows me to pick where the image goes. So I'm just going to pick a random spot here, and it's going to ask me questions down in the command line down here. Basically, they've already defaulted to what I want, so I'm just going to hit enter once and hit enter twice, and the dialog box pops back up, and I just hit OK. So maybe you can't see anything right now because it's a very small image. Okay, it did paste. It just pasted very small, and in comparison, that's how it is. This is the real size image from my computer compared to the size of the field that it was out there in real time. So how I made this bigger was I just selected the image and I selected one of the corners, and you can zoom out and you can just drag it and you can make it as big as you want, and it's just as clear. Okay, and that's just for simplicity's sake. I mean, I could have left it pretty small in there and zoomed in and drawn lines on it like I did over here on the left and this and that, but just to keep it the same size as the plan view, so I have a good relation within model space going back between one another. So that's up to you. But as soon as you get it to the size you want to leave it there, because for instance, when I change the size of this picture, it does not change the polylines. So if I grab this corner and let me turn my ortho mode off and I make it say smaller, then all of a sudden my polylines are over here. They're where they used to be, but they didn't move with the aerial image. So I don't want to change it once I get it set and start drawing things on top of this. Okay, so I'll hit Control Z to undo that, and REA should bring everything back. Okay, so two things. What I had down here to the right, let me just delete this one so it doesn't get any confusing. And yes, I will detach. The difference between the plan map down here to the right and the location map up here on the left is the plan map shows where things go. It shows where all the practices go in relation to one another, whereas the location map shows the general worksite area location within the county, the state, wherever. So the key here is to make sure you have some sort of identification marker to where you know where this would be located in the county. So in this case, if this was a specific county, I'll go to the county and I'll know that there's a County or Township Road 109 and County or Township Road 254, and somewhere in that county is where they intersect. So I know that that is where this project is. Okay, sometimes it can be kind of hard to find those intersections, but that's really all you need to find the general location within the county of where this project is to be located. So this is all the information that I include on the map. Is the stream, the yellow line is the property line, the orange hatching area is our general work area of where we're going to be. Okay? So that's all of the information I have in the model space. And using that information, I went ahead and used some standard grass waterway plan templates that I have created myself that I can just pull that information into and eventually wind up with a set of plans that can be checked and signed. So what I've done is I switched from the model space to paper space, and the first paper space I selected was my cover sheet option. And there's a lot of background to design this cover sheet, starting with the title block template. We have to make sure we're using the proper title block when we're using any kind of NRCS design references or specifications or anything like that. Okay, so anytime we use their logo on the title block, we got to make sure we adhere to their standards. And this is generally what they look like. There are some governing documents that dictate the size of the title blocks, and what I mean is the dimensions from this borderline to this borderline over here is 32 inches. Standard 22 by 34 page sheet size. So where that comes from is from the National Engineering Manual, Part 541. And I went ahead and pulled it up here. I'll bring it in. But the National Engineering Manual Part 541 is the part that specifically governs the drafting and drawing standards for any engineering plan we put together. Okay, so this is the general document, and for Ohio you can find this on the Ohio NRCS website through the engineering section. But basically it's got everything listed that needs to be on a set of plans. They also have a Part 541 standard title block information and the dimensionings of the title block. So let me just pull that over here. So bear with me. Okay. This is the Part 541 title block information that is required. So as you can see here, we have the title block listed here, and the information that should be in the management block and the agency signature logo, and all this stuff should be correct when you put together a set of plans. But they also have another sheet here that will give you the actual dimensions of the title block and border lines. So you can see up here, this is 541. So this is the National Engineering Manual, Part 541.10, standard ANSI D, which is the 22 by 34 paper, and ANSI B, which is 11 by 17 paper, which is half of a 22 by 34. So this is good for both cases because, as you see on screen, it's laid out for the 22 by 34, but if you want to use this for an 11 by 17 sheet, you just take all of the dimensions and divide them by 2. Okay. So for a 22 by 34 sheet, you can see that our title block should be 20.7 inches wide from border to border. Okay, so that's this whole distance from this side to that side. And the length of the borders should be 32 inches. That's over here. Okay, so that's from this edge of border to this edge of border, should be 32 inches. So that means we have some room to play on the outside of the paper for ease of printing. So as you can see, this template here that has all the dimensions for title block and the borders, it's got quite a bit of information on it. they've pretty much given us dimensions for everything we could ever need on a title block, and some of them are pretty specific. To be honest with you, the drawings that I do aren't exactly to these dimensions, and particularly not to the width. The drawings that I have, the one I'm working on right now, it has got the 32-inch length, but it's got a 21-inch width, which you can see on here. Technically it's supposed to be 20.7 width. Sometime in the last few years they've changed this at the national level. I don't know why. They never told us that, so that's why I'm still using the old dimensions. But still, this is a very useful sheet to get all your dimensions for your title blocks and borders. Now, the one thing I'll tell you is that this sheet is not located on the Ohio NRCS website. You'll have to Google NRCS National Engineering Manual Part 541 and you can find it in that Google search. But it is a little bit more difficult to follow. If you want, you can just take a look at it here, or you can print this page out after you screenshot it, and that should work just as fine. So while we're on the subject of references to use when putting together engineering documents for NRCS, there is one more reference that I should talk about before we continue on with the plans. And that is a reference from the National Engineering Handbook, Part 641, which is on the topic of computed aided design standards. And this is one that I actually do use quite a bit because it's one that'll help make plans more consistent, and by that I mean it'll help you give the right line widths to use, or what AutoCAD calls is line weights. It'll give you the right text sizes and the right drawing numbers to use and things like that. But what I use it for most for is for a couple pages here. This page here, this Appendix B within it, gives you, again, like I said, gives you the line widths for these two tables. And then this one here also gives you the text sizes for the different sizes of paper that you use. And for the most time, we use 22-inch by 34-inch drawing, or ANSI D. For those size drawings, these are the text sizes we're going to be using. Okay, now let's get back to the drawing. So we've got our title block and borders put together the right way. Now we have to fill the page with the information we need to build the project. And for the cover sheet, everyone does it differently, but what I like to do is put all my general construction notes, my Ooops and All Pups stuff, estimated quantities, and seating if there's room, the location map, as well as a contract block. And I'll go through all of those here pretty briefly. Some of the general construction notes for a grass waterway are very similar for all the different types of waterways we do in Ohio. Here I've got a list of 10 of them, and you can pause and take a look at them if you wish, but there's only a few that I'm really going to go over that are absolutely required to be on every set of plans we put together. The first one here is number 8, and that is our cultural resources note. Basically, this is saying if we find anything of significance, historical significance in the ground, we need to stop work immediately and contact NRCS to let them know. And that is something that we should definitely go over whenever we do a pre-construction meeting. And note 10 is a note that deals with NPDES permits for soil erosion and sediment control practices that we just have to be aware of that might be necessary if the construction of the project is larger and takes a longer time than what we're expecting. So just know that those notes 7 and 10 absolutely have to be on all plans that we do for NRCS. Just below the general notes block, we have a pre-construction meeting block, which also has to be in all the plans. And this is a sort of reminder that when the landowner and the contractor are looking through the plans before they start building, that they know, hey, we've got to set up a pre-construction meeting with the NRCS technician or the Soil and Water Conservation District technician so that we can get started on this project. And it's simple stuff. You just have to enter the phone number of the particular county you're working with, and it's just a simple thing to go over with the landowner when you drop off the plans. Just below that we have the Ooops and All Pups block, and this is a bit of a conversation piece, very important for any type of work that we do where we're disturbing the ground, which is most of the projects we do with NRCS. We need to be calling Ooops, which is the Ohio Utilities Protection Service. And we also need to be calling All Pups, which is the Ohio Oil and Gas underground protection service. Two separate entities need to be contacted through the design process of a grass waterway, of a pond, of a wetland. Doesn't matter. Whatever we're disturbing ground, we need to be calling those two numbers and getting two reference numbers. You can see for this example, I've done that here. I've called Oops and I've got a reference number, and I've called All Pups and got a reference number. Okay? This block is absolutely required to be on engineering plans. But when we make our Oops and All Pups call, if everything comes back to where we're all clear and there are no utilities identified in the area we're working in, everyone came in and replied, then we do not have to list any names of companies here in the block. We just go down to the bottom right hand corner and put an X through here. That signifies that there was no utilities identified within our work area. If, however, there are utilities identified, or if there are utilities that fail to respond within the required time frame, then we do have to list those utilities here in the box. And if they didn't respond, if they failed to respond, just put an X through the no reply box. And if they did respond and said there is utilities here within there, we have to put their name down and mark their address and put the phone number and just make it aware to the contractor that we have a utility in area. We have to be calling Oops and All Pups before we dig. We have to do that anyhow, but we just have to be aware that we may have to deal with a utility or the relocation of a utility to do this project. Below that big block, we have the actual notice to the excavator. So the block above was the called for design block, which means we called when we were in the design process. This box here on the bottom might be smaller, but it's no less important. Anytime anyone digs, the person actually doing the digging in Ohio needs to call those two numbers before they dig. At least 48 hours before and not more than 10 days prior to the planned commencement of excavation. Okay? So even though we've called them for the design process, the contractor still has to call them on their own. And it's going to be two separate numbers they're going to have. But it must be done before we disturb any earth in Ohio. On top of the Oops lock, or the Oops table, there's two lines, and this has become more common in Ohio plans, for the contractor to put the reference numbers when they call in. Now this doesn't have to go up here. You can put it down below the table wherever you want. But this is just kind of a reminder that the contractor needs to call, needs to be writing down the two numbers so that we can have it in the documentation folder once the project is complete. Now, whether or not they fill in these lines is or isn't important. It's whether or not they make the call. So if they give us the two numbers on a piece of paper, we can put that in a folder. It doesn't necessarily have to go in the plans. That's not required. What's required is these two tables right here. Pre-construction table where we're in the design mode, and then the construction table where right before they dig they're going to be calling. So if we move over from the top here, we can look at the location map information. And what I mean is this aerial image that I talked about earlier that was in the model space. So the way this aerial image appears both in the model space and in my paper space on the cover sheet here is by using a square viewport, which I can do by going up to the ribbon and under the layout tools, go under where it says rectangular. I can choose a rectangular or a different shape of a viewport, and I can select it, and I can draw a box to wherever I want it on the paper space, and then I can zoom in and out to get the part in the model space that I would like to display. Okay, so that's how I got that aerial image to be on the paper space. Okay, if I don't want it there, I can just select it and hit delete, and it gets rid of it. So that's how I get the location map brought up on paper space. The other things we need for the location map is we need a north arrow, and we need a legend that shows the different types of things we might see on the location map. So if there's an important drainage main that we need to show on the map, we can put that in using the green line here. If there is a property line, which we have here, okay, that's this line right here, we can draw that in and show that on the location map. If there's a ditch, which we have that here, we have a stream going through here, we can draw that on the location map. If we know the benchmark is in an area that's going to be outside of our plan view, we can put that on the map. Okay, so it's important we have the map along with a legend and a north arrow. And you can argue with me whether or not we need a scale. I think the more important thing to know whether this map is to scale is to know where the intersection point of the two roads are. If we know that, we can at least get the general location of where the project is located. That's the whole point of this map, is just to show the location, not necessarily to get standard measurements of detail off of it. We should also be listing somewhere on the plans the different type of soils. We could get detailed enough to where we show the soil boundaries on the plan map itself, and I would do that for a wetland or maybe a pond. For a grass waterway, it's not necessarily needed because we've already designed it based on the worst soil type. So it doesn't really matter what's out there. We've already got the design done. It does give us good information, though, to know when we do check plans to know which soil type is the worst, so that we can check your design calculations based on the worst soil. Below that, again, wherever you have your benchmarks, which I have them here on the location map, you can see benchmark 1 and benchmark 2. It's important you put some sort of benchmark description right next to those locations. Okay, so right here you can know TBM1, which is over here, BM1. We know that that's on a hub and a lath on the east side of the fence by the road. And the elevation of that point is 792.72. And the same thing with TBM number 2. So I have all that information on plan. The contractor can easily find it right next to each other. So just below the map, I've put my estimated quantities table. This is the table where we have all the estimated, and I stress estimated, not exact quantities, for the grass waterway. The contractor will use this table to put together a bid to give to the producer or to give to the owner of the ground to bid the job. This is how they put it together. And we want to be as accurate as possible, but we need to reinforce that this is not a bill of materials. Okay, so they're not going to get paid by cubic yards or by pounds of turf type tall fescue or fertilizer that they put on. This is just what the quantities we expect will take to get the job done. And that's important to remember. Just below that, we have the project information, and this is just some general information that is very helpful for us when we go ahead and do the review of the project before it's approved. It gives us just general information that has to deal with these plans. And below the estimated quantities box is the contract block, which we also use for the bill of materials block. This is, as opposed to the estimated quantities block, this is what they would get paid on for a cost share reimbursement. So what I'm saying is that for the first line here, for the rock riprap chute, okay, we have designed 58 cubic yards and we've planned for 55 cubic yards. So if the contractor were to install, say, 40 yards of riprap, then something's wrong. Something changed out there in the field that either required that change or that they didn't do a good enough job getting it done because they didn't use enough rock. So this is where we take care of the bill of materials section of it. This is the exact values that they're trying to hit with the actual construction of the grass waterway or rock chute or subsurface tile, whatever it might be. So this contract block is based off, if it's an equip contract, you'll pull it right from the equip contract information. So all of your contract item numbers will be on here, listed practices, the year that's scheduled, the units that it's measured in, and then the planned quantity that was in the conservation plan, and the design quantity that's in these plans itself. And beyond that, once the construction is complete and the as-built has been done and taken, we can put those values right here in this category by hand, and we can mark down who did the as-built and the date they were done. And from the three values of the as-built quantity, the design quantity, and the planned quantity, we can determine which quantity they are eligible for payment. So for instance, if the design quantity and as-built quantity were bigger than the planned quantity and we couldn't pay any more than the planned quantity, then that's what they would be eligible for payment. If the planned quantity was bigger than the design but smaller than the as-built, then again, we'd still only pay the planned quantity. It just depends on the situation for what goes in this block, and that's kind of where experience comes into play. Beside that, we also have our construction approval block. If we work our way up to the top, you'll see this big block up here is my seating table. In this case, it's a grass waterway, so we're going to have a lot of seating here. And it's a specific mix type that I got from the seating appendix. It's a standard block that is very easy to see how much seed is required and the seeding dates that they need to go by and the preparation methods and things of the sort. So this is available on the Ohio NRCS engineering site under the AutoCAD section. You can get this under the standard templates. And just below that we have the final block for the standards that are being used in this set of plans. So in this case we're using the 412 standard, which is grass waterway. We're using the grade stabilization standard, the subsurface drain standard, and the critical area planning standards, all for this project. So other than that, we're starting to run out of room on the cover sheet, so there's really not much else we can add to it. However, in the process of going over this plan, I realized that it was missing one final piece, and that is a note that we should be putting on all of our plans that have multiple practices with different job classes associated with them on the plans. And that's this note right here that I'll talk about in a second. So you're going to see me here move some things around to be able to get it to fit on the cover sheet if I can. Okay, so what I've done is I just took the standard reference block that was here in this section, and I've moved it up here underneath the temporary benchmarks because I really had no other space to go with it. And I've added this construction approval block. You might be asking, why would you need that when you already have the construction approval lines down here in the contract block? Well, the purpose of the construction approval block is for the entire job. So basically, this one job for this grass waterway is a job for a grass waterway, a rock chute, and a subsurface tile, which all three might have a different level of job class required. So while I might have job class approval for the grass waterway and for the subsurface drain, I might not have it for the rock chute. So this block is intended for the final signature of construction approval. Once everything is done, the person that has the job class approval authority for everything needs to be the one who signs this. So that might be a more experienced technician, that might be your area engineer, and in some cases that might be the state engineer. Okay. Over on the title block, there are some small bits and pieces of information that do need to be filled in with each set of plans. On the bottom right hand corner of the title block, there's three pieces of information that I'll talk about. The first piece of information here is the file name. And the file name is simply that, whatever you saved this file to. So for instance, if you look up here in the left hand corner, the file name for what I've been working on is called Plan Prep Grass Waterway, or plan-prep_gww.dwg. That's just the file name. If I had to go find it on my computer, I could type that in, it would take me right to it. Just below that is the drawing number, and this is really whatever system you have in place in your county or in your area. This is a way of keeping all your drawings that you do throughout the year organized. So you can see in my case, I've got the organization that I work for, ODA-DWC-DSWC-A1, that stands for Area 1, that's where I'm at, -16, that's the year, 2016, -05, because it's my 5th drawing of the year. So that's how that works in my case, and maybe in your area, or maybe in your county you have a different way to do it, but you have to have some kind of drawing number that you're able to reference drawings throughout the year. And the last piece down here at the bottom right hand corner is the sheet numbers, which seems like a small thing, but having the right sheet number in the right place can make things much easier to find through the review process. Just above that, we have the standard USDA NRCS logo. This is the one we should all be using. We don't want to see the old NRCS teardrop logo. This is what we need to be using on all of our plans. Just above that is the title of the engineering set of plans. And you can kind of organize this your own way, but what I like to do is I like to keep the county name in which the plans are applicable, the sheet numbers again, and the township, and I might even put the section number here with the township, the producer name, the type of project, and what this sheet is. So in this case, we've got Bob Smith, this is an equip grass waterway, and this is the cover sheet that we're looking at. And the top part of the title block is just your design, drawn, checked, and approved block that you can fill in through all the processes. So in this case, I've done all the design work and I've done all the drawing on AutoCAD. I'm going to be both of those lines filled in, and then the person checking and approving the plans will put their names and dates here. Okay, looks like a lot of information for one cover sheet for a simple grass waterway, but it checks a lot of boxes that we need checked since we work with federally funded dollars. The second page is a much simpler page. It's the same image we saw on the model space. It is the plan view of the grass waterway, the rock chute, and the tile layout. Okay, so again, like I showed you on the cover sheet, all I used was a rectangular viewport, and I basically made the viewport as big as the entire sheet here, and I zoomed in to the plan view area. Simple as that. Other than I added a north arrow and a scale, and I wrote what the scale was so that it was easy to figure out. Now when we talk about scales for a set of plans, it's important that anytime you zoom in and out, make sure you do it at an even increment. So for instance, when I click in the viewport, I'm now working in model space. You can see down here at the bottom that my scale is 1 inch equals 30 feet, which is what I have written here. Okay, but when I unlock the scale, I can now zoom in and out using the wheel on my mouse. So if I zoom in just one click, what's my scale? I don't know what that is. It's a very small number that represents probably 1 inch equals 23.67 feet. It's pretty much useless because if I pull out a ruler and I try to figure out what 1 inch equals, if that's 23.67 feet, what does 2.25 inches equal? And it just becomes a wholly complicated process, and just avoid all that. If you send me a set of plans that has that kind of a scale, I'll send them right back to you and I'll say try again. Okay, because small things like this can make it very frustrating for a viewer to figure out what's going on. So what I'll do is I'll just set the scale back to 1 inch equals 30 feet, right like that, and then I'll recenter it to, it's right there. Okay, so get the scale right, and once you do that, you can add the scale, and it's pretty simple. Once you're on the layout tools in the ribbon, you just go over to the scale bar button and you can click it and then pick whichever scale you want to use. Okay, select the viewport and select the scale bar division and the scale ratio. Sometimes when this comes up, you'll see non-whole numbers. So for instance, 60.0001. For simplicity, I'll get rid of the 60 point whatever and just make it 60, and I'll change this to 12360 only. And I can put the scale bar, let me get rid of the orthogonal, wherever I want. Okay? And same thing with the north arrow. You can simply go up to the ribbon, find a north arrow button, And once you click it, you'll get several options that pop up, and just pick one arrow and use it. And you can also change the size of the arrow by selecting north arrow and clicking this triangular shape here and just drag it out. It'll make it bigger or smaller. Okay. That's it for the plan view. The third sheet is the profile view. So again, this is a profile we've already done. We've done it in one of the previous CAD webinars, but we've pulled it in using another viewport. And you can't see the viewport because I've hidden it. I've done this by setting my boundary for the viewport onto a layer which I turn off for this sheet. So I can turn it on and off by going to the Home tab, and just like any other layer, I can pick the layer drop down, scroll to where that layer is that's turned off, and I can hit the light bulb. And when I turn it on, you can see that my viewport boundary is there, and I can click it and I can adjust it as needed. But for the plan prep start, for the part of that, I don't necessarily need that boundary line on the plan, and it's just an extra line that kind of makes things confusing. So I'll just go ahead and keep it turned off so that I can't see it. Now, even though that it's turned off, you can see that I can still get in that space for the profile and adjust it if needed to. Okay, but I shouldn't need to because I already have that profile complete through the model space. So this is my profile. You can see that I have some labels that I've added on here for the finished plans. For a waterway, we want to make sure we have a minimum of the design grade, the existing grade, which is this green dashed line here, and we want to have some marker of where the low bank is for the edge of the grass waterway. Now, the way we designed this is we don't have a low bank line. We have two bank lines, one for each side. So we have a left bank line and a right bank line, and we can use this to figure out which one is the low bank line depending on which station you're at. So I've got all those labeled, and I've got those different colors. Now, the colors, generally when we talk about plan preparation, we don't want to have any colors on the plans. We want them to be all in black and white. So we'd prefer to use a different line type, so we can have dashed lines or dot lines or things like that. But I like to use colors in the profile just because it's easier to see for the official design set. Now, when you make copies of these, those lines may go away, but in general, for the signed plans, for the official copy for the office, I like to have those in colors so they're easy to see. I've also got some other labels here. I've got the start of the rock chute, so I know that the rock chute starts at station 0 plus 00 and continues until station 42, which is the station where the grass waterway starts. So I also have that labeled here. Grade breaks start at station 0 plus 42, and it tells me the elevation. That's for the grass waterway. I make sure that the design grade of the grass waterway, which is the blue line here, I make sure that it has the grade printed right on it so that there's no confusion on what the grade is for which station it's at. You might have, on many of your grass waterways, you'll have multiple grades per grass waterway. And then so you'll want to label each one of those sections for the different grades on the profile. But in this case, I only have one grade, so we'll leave it at that. I also have a tile going next to the grass waterway to keep the bottom dry so we can get grass well established in this grass waterway. And for this tile, we're using a 6-inch tile because we're collecting other tile that's in the field, and that's the maximum cost shareable size we can use for the payment items within CRP. But I've simply placed this tile line slightly below, well, not slightly, approximately 1 foot below the design grade for the grass waterway, and that's so we can get a hydraulic movement for the water table where the waterway center line is down to the tile. Okay, well, you wouldn't want to have your tile placed 1 foot above the grass waterway on the edge, because then it wouldn't do any good to drain the center of the waterway. So you want to have it down about 1 foot below the center of the waterway elevation. But that's just a polyline that I have a certain line type on here that shows it as a tile. Again, I've labeled the center line. I also labeled the ending station for which the grass waterway stops. So that way when I go out there to lay it out, I know that station 7 plus 50 is where I stop setting the flags, and that's the point where I have the contractor blended out into the field. But that's just the standard profile that we've built in the previous webinars. I've got a couple other details here. I've got the erosion control blanket details. Basically, anytime we build a grass waterway, we better be using erosion control blanket. We've become more and more reliant on these to prevent waterway failures when they are establishing grass seeding. We've just found that when you use an erosion control blanket with straw, that your establishment of the grass waterway's grass inside of it is much more successful. So I have those details. I've got the details for the outlet of the tile. So that tile is going to outlet into a ditch. So we have to make sure that the outlet of that tile has some sort of animal guard on here. In this case, I've chosen the 6-inch pipe animal guard with the 3 and 16-inch bolts with washers and nuts. Whichever one you use is fine. Just make sure you have the detail on your plans. I have the detail for the subsurface drain installation. So in this case, it's a 6-inch tile. So this is the detail you use for a tile that's between 3 and 8-inch diameter. And in this case, it has the V channel support for the tile, whereas the bigger tile will have sort of the trapezoidal channel underneath. But I don't need that detail because this plan doesn't have a tile that's bigger than 8 inches. So I'll just put this one on the plans. Up here is maybe the area where the contractor is going to be using the most, and it may be the only area of the plans the contractor actually uses in the field. This is where the data for the grass waterway is. This is where the contractor knows, okay, at station 42 I'm starting the waterway. I know that my grade is 0.9% slope. I know I'm doing a parabolic waterway, and to build a parabolic waterway I know it's got to be 40-foot top width. That's right here. I know that to get the shape of the parabolic shape, I know that 3/4 of that top width is 30 foot, and then half of that top width is 20 foot. And the depths at those distances, as shown by this typical detail up here, are listed as below. And again, we've developed those informations in the previous design steps, so I'm not going to go over those, but just know that the contractor will be looking at this area to know that, okay, when I'm in the center of the waterway 10 feet from the center line, that my depth from existing ground should be 4/10. Okay. This also has some general information. It's got the length of the waterway, the seeding width, and the seeding area. That's a little less important to the contractor because they're going to build it to the length we lay out in the field. They're going to seed to what's been disturbed. So again, they're really going to focus on the design information and how the grass waterway is shaped and the details for which it's developed. Just like above for the grass waterway, I've got the design information for the tile. So again, the contractor will look at this and say, okay, I got to start the tile from the beginning, and it's going to go all the way to the end of the waterway. It's going to go on a 9/10 grade. It's going to be a 6-inch tile, and I just have to know that I put it a foot below the center line of the grass waterway. And then I can follow the path of the grass waterway all the way throughout it if it makes turns and bends and whatnot. So that's it for the profile view sheet. This is how I put it together. Again, if you do it slightly different and it looks slightly different, that's okay, as long as you have the general information that tells the contractor how to build the grass waterway, the information they need to know to get the job done. The fourth page we'll go over is the cross-section page. And again, these are cross-sections that I've developed in the model space, and I've just pulled them right in like I have the other sheets through using a single large viewport, starting up in the top left-hand corner and making it the whole size of the page. So if I double click in here, you can see I'm now in model space, and I can adjust these cross-sections. But I don't need to now that I've already done that, so I'll get out of model space. And the cross-sections are sort of a debatable area on whether or not to put them on plans. Technically, according to specifications, we are not required to put cross-sections, the actual cross-sections, on the plans. We are required to put a typical cross-section shape, which you saw on the profile sheet, but we're not necessarily required to put on a cross-section sheet of what's existing and what's designed. So that's really your choice. I will tell you this, after working with some experienced technicians, that this makes your life much more easier and much more simple when you're out there construction checking a grass waterway as it's being built. Because what you do is you go to these standard stations, so I'll go to station 300, and you can zoom in here on the cross section for station 300, and you'll know, okay, in the center line, my elevation should be 787 at that station. So I can take a shot, whether I have a GPS unit or a laser or a total station, whatever I have, I can take a shot there. I can say, hey, you're 3/10 high, you're 2/10 low, whatever it is, or you're right on the money. Okay, but then to get the shape of the cross section, to make sure that the contractor is getting the proper parabolic shape, I can go out to my standard checkpoints, which is the standard 9-point checks. Okay, so what that means is 7 points in the center of the waterway from edge to the inside, and then 2 points outside the grass waterway. If you look back to the profile view sheet that I just came from, you can see that this is the typical shape. So what I did is I put a checkpoint here at the tops of the waterways, so that's the full width, a checkpoint at the 3/4 top width, okay, and a checkpoints at the half top width, and then a checkpoint right in the center. And that's your 7 points inside the grass waterway you need to be checking during construction. And then you'll also see on the cross sections that I put a point outside of the grass waterway to make sure that the contractor is properly disposing of fill and grading towards the grass waterway, so that we're not blocking any water from getting into the grass waterway. So on this cross section, you'll see I'll have all those set up, and again, all those were developed in a previous webinar. You can go back, you can learn how to put it together and get the labels right. But I can run right out here and I can say, okay, at 3/4 of the top width, which is 15 feet from the center line, my elevation should be 787.8. So you'll notice that I don't have any of my elevations down to the 100th of a foot for accuracy. When we talk about grass waterway construction checking and as-builts, we only have to be accurate to the nearest 10th. And when you're doing any kind of earthwork out in the field, a 10th is really all you can be accurate to at any one point, because if you put your survey rod in one spot, it could be a certain elevation. If you put it right next to that one spot, it shouldn't change, but because of the clumps of the dirt and things like that, it could go down a few hundredths of a foot. So that's why we're only staying accurate to within a 1/10 of a foot. But you can see here at 15 feet from the center line, my elevation should be 787.8. If it's 787.9 or 786.3, I'll know that it's off by so much, and I can inform the contractor that they've got to come and address that. Some contractors will use these to check themselves, but most times not. It relies to the inspector out there to check these points within a grass waterway to make sure that it's being built properly. Okay, so those are the 7 inside. Again, I also have 2 on the outside, so it would be this one here, offset 24.7. That means that I am 24.7 feet from the center line of my grass waterway on the left side. So that's outside of the design width, but we had to set a point there because from when we developed this cross section, that's when the designed cross section meets the existing ground. Okay, so that's when this black line meets the dashed line. Okay, so that's the point I want to check when I'm out in the field. And the same thing on the right side, the point where the existing ground meets the design ground is 32.1 feet from the center line. So I can walk out from the center line that far and my elevation should be exact. So again, cross sections, while they might be debatable, they're extremely helpful, that's for sure. And when you do any kind of as-builts for a grass waterway after construction, you are going to have to take this information and either put it into a survey book or put it right on the plans. And it's just much easier when it's already laid out on the plans to do that. So that's my 2 cents. So that was the section view page. The last page for this particular grass waterway is really any other items that might go with it. The first 4 were really just a grass waterway. So I have the cover sheet, I've got the plan view, I've got the profile, I've got the cross sections. That takes care of my grass waterway. This grass waterway has to outlet somewhere, so in this case we're using a rock chute. Now I'm not going through any of the design processes here, or why the elevations are what they are, the lengths or this and that. That depends on the site, and you're going to have to use your experience and your knowledge to know how to develop that. But for the plan itself, it's fairly simple. This is a standard drawing that is located on the Ohio NRCS engineering site. You just go to the CAD resources and you should be able to find the rock chute drawing. This is a base drawing that when you load it into CAD, the distances and the measurements for the rock chute will all be blank, and you just fill them in based on your design. Okay, so it's fairly boilerplate. You just get all the details, you slap them on your sheet, you fill them in with your numbers, and you calculate your estimated quantities. Finished. Okay, so that's it for this waterway. There was really no other practices associated. You could have had a couple other things going on. Maybe you had, for instance, a underground outlet like a French drain, or you had a riser pipe that you had to put some kind of orifice on, or you could have had a different grade stabilization structure. You could have had, say, a concrete drop box. You could have had a rock pad, different things like that that you can add to these plans. But that's really dependent on the particular site that you're working on. As you can see, when I went through all these pages, the title blocks all stay the same. So if I flip through these real quick, you'll see that the title blocks won't change much. Okay, they're all the same. The only thing that changes on the title blocks as we go along through here are the sheet numbers and the title of the page. So for this case, it's the profile page. If I go to the rock chute page, then you'll see that the sheet number has changed, as well as the title of the page, which is the rock riprap chute. So at this point, I have got the plans done. They are ready to be printed, and they are ready to be checked and approved. And then once we have a pre-construction meeting, we can begin construction. So the last step in this webinar is to figure out how to get these 5 sheets put together so that I can do a nice printout and get it stamped by either an engineer or signed by someone who has the appropriate job approval authority. What I do is, instead of printing directly to a plotter, which I can certainly do that at this point, I can go ahead and hit plot and print each page to a plotter. That's certainly acceptable, and you can take those paper sheets and you can take them to the reviewer and the checker, and they can do that. But since so often I send plans to different counties that are further away, I don't want to have to be transporting back and forth the actual hard copies of the plans that are just going out for review. So what I like to do is I like to turn these plans into a single set of PDF sheets. So I'll have one PDF file that'll contain all 5 sheets, and then if someone wanted to, they could print these PDF sheets out on their plotter, and it would look just the same as I did it here from CAD. So I'll go through that for this webinar. The way I go about printing to PDF is up in the top left-hand corner here. There's the big A, and you click it, and you can hit print and go to batch plot. Okay, that's how I do it. I do a batch plot so I can print all of these sheets together. Before I do that, I want to make sure that my page setup is how I'd like to have it. So to check my page setup, I'll go down here to the tab of the sheet that I'm currently on. It doesn't matter which sheet you're on. You can do this on any of them. Is you just right click, go to Page Setup Manager. I already have one created for a PDF 22-inch by 34-inch paper, but I'll go ahead and create a new one just so you can see how it's done. So I'll create a new page setup, and I'll label this one 22 by 34 PDF Plan Prep, since that's the name of this webinar. Hit OK. I want to change my printer/plotter from whatever it was on before to what's called DWG to PDF. Okay, that'll basically take the plot function and just transfer it, export it, let's say, to a PDF instead of going straight to a printer. I want to make sure I get my paper size right. Again, if you're following NRCS specs to a T, we need to be on ANSI D, not Arch D. Arch D is the 24-inch wide paper, which a lot of districts still have, but if we're going to follow NRCS specs and do it right, we're going to select the ANSI D paper, which is right here, the 22-inch wide paper. Okay, so we'll select ANSI D paper. And what I like to do is to get my title blocks and borders centered on the paper, I'll change the what to plot question from layout to extents. Then I'll check mark center the plot, and I can just preview that by hitting the preview button. So as that comes up, this is what it will look like when it's created in a PDF. Okay, so I can zoom in and make sure that the title blocks and the borders are equally portioned from the edge of the paper everywhere, and everything looks correct on screen. Okay, I'll exit back out of that on the top left hand once I'm done. I don't want to mess with the plot scale because I have developed these drawings so that they're already 22 by 34 borders, or more specifically 32-inch by 21-inch borders. But for instance, if I was printing to an 11 by 17, I could change my scale to 1 inch equals 2 units, and that would effectively cut these dimensions down by 2, and they would fit on an 11 by 17 sheet. If I've got any plot style tables up here, I want to select them as well. If, as I said before, you have a lot of colors on your title blocks, that's frowned upon, and you may get written up on a QAR review if you have a lot of colors. So normally there is this plot style here that we call monochrome, and that turns all the colors into black lines. Okay, I'm just going to go ahead and select that and show you what that does. So you'll see down here on the right on my page, the title block portion of the USDA logo is in color on this page. Watch what happens when I go ahead and preview it once I've changed to the monochrome plot style. I'll hit preview, and there it turned black. Okay, which is perfectly fine and acceptable for all cases. The only thing that the monochrome plot style will not change black would be like an aerial image that's in your viewport that's being displayed. Everything else besides the aerial image will turn black, including your profile lines, your cross-section lines, anything like that is going to turn black. So you can select that if you'd like. I also like to check mark this one right here, this plot transparency, just because sometimes in our details there's a transparency part of, say, a box or something like that. We're not supposed to do that, but occasionally it happens, so I check mark it just in case. And then some of these other things you can play around with. I leave most of them check marked. The key thing is to just preview your drawing to make sure it doesn't turn anything off or on that you don't want on your plans. Okay, but that's it. Effectively, I haven't changed very much. I just changed the paper size, and I moved what to plot to the extents, and then changed the plot style as needed. I'll hit OK, and you didn't see anything happen. Hit close real quick, because all it did was created a template for how to print this drawing. It didn't change anything on screen. If I wanted to do that, I had to modify the actual rock sheet itself. Okay, I just changed a printer template, but I have to do that before I go ahead and plot it. So let's go back up to the big A and select print, and we want batch plot so that we can do all of the sheets on one file. And the sheet list you don't have to worry about. You want to make sure that you publish to PDF. Okay, you want to make sure that we've got a high quality PDF coming out so that we have very clear lines on our profiles and on cross sections and things like that. You want to come down here to where all of these sheets are listed and make sure you have the ones you want. So for instance, this has the cover, the plan view, the profile, the cross section, the rock shoot, which all of those I want in one file, but it's also got the model space, which if I selected that, it would just give me an extra sheet that shows everything in the model space, and it's really useless. Okay, So make sure that when you do this, you go ahead and select that one and hit this button here with the red dashed line that says remove sheets, and select that. So at this point I want to change all the page setups to my 22 by 34 PDF that I created, just so that I know that when they're created in PDF, they are done to the scale and to the center of the plot and everything that I picked, so that they appear the way I want them. So this is an important step. Make sure you select all the appropriate page setups for this. I can go here and change my publish options by changing the location of where the file is to be saved. Now, the important thing here is not necessarily the location of where you're saving it, but to check mark prompt for name, because that'll ensure once you publish this, it'll pop up with a dialog box asking you where to save it and what to name it as. If that's not check marked, it'll save it automatically into this location, which is fine. The problem is when you have different projects, you have different locations popping up in them. So it's just important to keep the prompt for name here check marked. And also check mark the multi-sheet file. That ensures that all of these are turning into one PDF file. It just makes it a lot easier to transfer back and forth with people. Okay, so that's the way I want it. So I'll hit OK. And when I hit publish, it should pop up with where I want to save it, which I don't want to save it there. I'll just save it right to my desktop. And I'll hit select. It's going to ask me if I want to save the current list of sheets. Just say no here. It doesn't really matter, because more than likely you'll have to do this more than once. But even if you don't, it'll still save the PDF fine, and you'll still be able to do this process like before. So I'll just hit no again. And it'll take a little bit of time to do this, because this is a process in the back to draw all this. You'll get a couple of dialog boxes popping up. You'll see here, this one just tells me that it's printing. And you can also see this down on the bottom right hand corner. You'll see this little button that looks like a printer with a piece of paper going through it. That tells me, if I hover over it, that a published job is in process. So at this point I can continue on with another project, or I can continue on with this one if I have changes to make or for whatever reason, but I'm really just waiting until that process is done. Once it's done, I can review it in PDF form. Okay, so it popped up here with another dialog on the bottom right hand corner. It said plot and publish job complete. There was no errors. That's always good. So then the PDF should be saved where I asked it to be saved. And you'll see right here on my screen I have a plan prep GWW PDF that was created. If I open that up, you can see I have a PDF of my grass waterway plan. And you can see I've selected the monochrome so that there's no color except for the aerial image. Like I said before, anything that's on an aerial image or anything that's a hatching will still show up in color. So you'll see that on the cover sheet. But everywhere else, like the plan view, it's all in black. The profile view, it's in black, and you'll see that what I was talking about earlier, the left and right banks, they are the same line type, which had I done a better job, I would have changed their line type so that I could have followed them more properly. But I do have them properly labeled so that I can follow them if needed. So let's zoom back out here. And I have a PDF set of a grass waterway plan with a rock chute that's ready to be sent off to be reviewed. Again, I can still print off these PDFs right to my plotter. For instance, I have a HP DesignJet T520, which is pretty common in our office, but if you have something else, you can select that. Change the size of the document to D. Hit OK. And we want to do actual size. This is important. Anytime you have a PDF with plans, or even if you're printing straight from CAD, make sure you're printing to actual size. Because what will happen is that if you don't do that and you select the fit option, it will be slightly smaller, 2% smaller than it would have been for the actual real size, which isn't a big deal unless you start using the scale. So the scale that I said earlier that was 1 inch equals 30 feet, that's not necessarily true anymore because I printed off 2% smaller. I'm not going to print this out. And that concludes creating a grass waterway plan from the first step of building a surface to putting the plans together. Thank you.